Global warming is an ever-pressing concern for humanity.
Our goal was to zero in on one of the biggest contributors to global warming, the heat island effect. We want to slow down the process of heat island effect by cutting down the amount of heat buildings absorb throughout the day.
Each part of this system was designed after plants and animals. The camel's nasal cavity allows the camel to reabsorb the moisture back into its system. This happens when the airflow is interrupted by thin walls. Because of the increased surface area, it is able to be more efficient at losing less moisture. One of the structures we mimicked was the structure of wheat.
To keep the whole plant cool during the hotter parts of the day, the leaves use a capillary action to pull water into them and release it as vapor, cooling down the plant and pulling the water up into the leaves at the same time. Cathedral termites.
These insects create massive structures in hot parts of Africa. To survive the heat, they make thousands of small holes at the base that then allow air to travel through, cooling it down while hot air rises through center shafts, creating enough suction to pull more air in.
The Saharan silver ant. This unique ant has a thin layer of hair that is transparent, allowing the sunlight to refract off its body, causing it to look reflective, or silver, and keeping it cool. This cactus uses its wavy pattern to create a shadow on its core, while the edges of the waves allow heat to escape, allowing it to endure hot temperatures.
After sketching, plussing, and testing mock-up models, we created a prototype of our design. We wanted to know what someone with more knowledge in the field of heat transfer thought of our product, so we asked an expert in thermodynamics at Long Beach State.
I really like this design because 3 layers that you have, they are sort of working in sync and they're doing different things as well. This is supposed to be the first barrier that absorbs the heat from the sun. So it would heat up from that direct absorption of sunlight. There will be a flow of air across this structure into these holes, and once it gets hot, this air, whatever air is in here, is going to rise up. The third innovation that you have here is this capillary layer. Surface tension, it would automatically absorb the water, right? And the water will evaporate. And what that evaporation will require is a lot of heat absorption. So if this is right next to your inside wall of the house, the wall will cool down.
This is Phalanx. It's a 3-layered system that's able to cut down the amount of heat buildings absorb from sunlight during the day. This system would get its water from wasted gray water. It would allow for some of that water to run along the base of the phalanx, where a capillary mat would pull it up into its system. Our design can be implemented on existing buildings without the need for dramatic architectural alterations. Phalanx is the perfect shield to defend against global warming.